Good day, this is Lucas Olenek from Wilger Industries here in Canada. Just here today to help you through a kind of a tip selection or example tip selection for 7.5 gallons of glufosinate, or Liberty is a trade name. In this application, we're going to be using a pulse width modulation sprayer, similar to a system like Aim Command, Hawkeye, Exact Apply, or Pinpoint, similar to that in the industry, just to name a few. With this, we will go onto the website wilger.net. Alternatively, Tip Wizard is available also on app, whether it be on Android or Apple device, or offline versions as well. So nonetheless, regardless of what viewer or program you're using to view Tip Wizard, the results themselves will be the same, or at least near identical, just in the layout and such. So from that, we'll begin. So Tip Wizard, we'll start out with some search information being needed, specifying the application rate unit. So in this case, we're going to be using US gallons per acre. Also, select the spray system, which will either be a rate controlled spray system or pulse width modulation spray system. In our example, we're going to be using a pulse width modulation system. Also, at any point in time when you're using Tip Wizard, there will be little icon light bulbs, which give you an idea of what kind of systems are available, naming a few, but also to some tips and tricks or notes here and there as well. So feel free to use those as your resource as well. So select pulse width modulation. For the search function, there's 3 options available, 2 of which are going to be more commonly used. Search for spray tips. That'd be primarily if you're starting with an application and you need a nozzle for it. Specific tip lookup will be more so if you have a nozzle already, whether it be it came with the sprayer or you just have them on hand already and you want to look them up. The third being favorited nozzles. So that's more after the fact. You've picked nozzles and you favorited them. You can isolate those ones that you have favorited in their own search as well. So we will search for a spray tip. From then on, we'll be asked to input a little bit of information as far as the application itself goes, starting out with the application rate. So the application rate can either be typed in, 7.5 gallons, or there's a drop-down button as well. Again, you can type in whatever rate you need, so whether it isn't exactly 7.5, not a big deal. Just type it in. In our case, we are doing 7.5 gallons an acre, so we'll be there. So the max spur speed, again, typically the average spur speed has been used to pick nozzles previously, but with pulse width modulation sprayer, you have more flexibility for your speed range. So while this wouldn't be the absolute maximum speed, think of it as your average and then a little bit. So in this case, we're going to be applying at 15 gallons or 15 miles per hour. Sorry. So we'll type that in. Again, Tip Wizard doesn't mind if you have any, 15.25 is where your sprayer goes naturally, so be it. But 15 we'll plug in. We'll also ask you to input the pulse width modulation system. So because there is a little bit of differences between different pulse width modulation systems, there is a requirement to add it. Or select it. The reason being is that there's a little bit of pressure drop through the solenoid, and between some different configurations and designs of the systems, there will be either greater or lesser pressure drop. So that factor is accounted for in Tip Wizard, and it is important to enter that. For the nozzle spacing, typically you're in 20-inch spacing. Again, 15-inch spacing might be common in your area, or even narrower, or even 18-inch spacing. Nonetheless, you can plug in whatever your nozzle spacing is. Again, if your nozzle spacing does not show up in the drop-down menu, you are welcome to type it in as well. So we're going to be using 20-inch spacing, and we'll start from there. For spray tip angle, so that's the physical angle of the spray pattern coming out of the nozzle. Typically 110-degree nozzles are commonly used. There are some situations or sprayers, primarily older sprayers or spot sprayers, that will be using narrower angle nozzles, so 80 degrees. But more often than not, 110 degrees might be the standard. There are some alternatives that have narrower angles than that. They are freely available, but sometimes they haven't been introduced into Tip Wizard and such there as well, because they are more specialty nozzles. So we'll select 110 degrees, and then we'll come to the target droplet size. So to give you an idea, target droplet size is more so where guys get hung up a little bit, because there's a little bit less information out there sometimes, or there isn't a clear understanding of the information that's available. So primarily on every chemical label, you might see a spray quality listed. You'll see something written in the wording of spray with an ASABE S572 coarse. spray quality being coarse, naming the classification itself. There might be some alternatives. You might see ASAE. So instead of ASABE, that's just a differentiation of the standards body. So they would be the same. So that's most chemical labels will have that. Make sure you're deferring to the ground application chemical label. If there is air and ground, keep in mind there is that difference. More often than not, most of our chemicals that we're applying in kind of North America here are usually into the medium coarse, very coarse, with some being into the extremely coarse and ultra coarse being more restrictive herbicides or applications. So most of the time that'll suit us fine. But tip wizard's a little bit different in that you can actually plug in a target droplet size. So 50% of your spray is going to be smaller than that, and 50% is going to be bigger than that. You can think of it as your average droplet size, which isn't completely accurate, but it's kind of an easier way to think of it. So it's the droplet size that we'd be targeting to get our meaningful spray quality of what we're trying to do. By all means, you still have to follow the chemical label. So if the chemical label dictates that you have to spray a coarse spray quality or coarser, then definitely make sure you're accommodating that before you're talking droplet size. So in this case, we're spraying glufosinate, which is a contact herbicide. So we could either go into the spray quality and select medium or coarse. Often that'd be where you are. There is the ability to use a droplet size, which is almost like a filter or a kind of a cheat code, just to tailor it a little bit closer to where that balancing act between drift and coverage might be. So for this example, for Liberty, we'd be plugging in 330 microns, which is a good all-around droplet size to be around for that kind of application. That there isn't the most drift sensitivity because it is kind of a contact burning application. But at the same time, you do need a whole lot of coverage as well because of how it works. So 330 microns is a nice place to be as it all around. But keep in mind your conditions differ than somebody else's. Often the case is the field next to you might be spraying a lot more drift sensitive chemicals than you are. So you can actually change that droplet size to adjust for that. So even though 330 microns might be a good bench line, what you might do if you're a little bit more drift sensitive, just in general, you might be bumping that number up. So the bigger the droplet size number, the coarser the spray. The coarser the spray, the less drift. But keep in mind also there's the whole side of it that with the coarser the spray, the less coverage as well. So it is keen to balance that coverage and droplet size pretty well. But so in our example, we might be 330 microns. If you're drift sensitive, you might be in around the 350 to 380 microns or somewhere around there. But that's something you can do with a droplet size that's a little bit tougher to do with the categories. So we'll go on. We'll use 330 microns. If we scroll down, we'll get into the results. So the results are sorted by size. Size first, not necessarily the best one first. So what you'll find is that it'll go from smallest to largest. And if you click on them, what we'll do to simplify the tip selection process is actually isolate the speed and pressure first, ignoring the spray quality and everything else. Because the pulse width modulation systems have such flexibility, often it can be overwhelming for the amount of nozzles or the sizes of nozzles that are available to you. So by isolating the speed, pressure, and duty cycle, that can give us the size qualification first, make sure the nozzle size will work before we consider anything else. So in this case, we have an MR series, MR being the kind of mid-range drift reduction nozzle, in a 110 angle and an 04 size. So with this, it'll give us flow capability. It doesn't differ from an 04 nozzle of a different brand or a different series in that the flow rate will be the same. So 0.4 gallons per minute. Again, just so you know, a red nozzle is a red nozzle is a red nozzle. So from left to right, we'll see the pressure. So that's the gauge pressure. That's what you'd be setting your cab to. Your speed range. So that's the physical capability of the nozzle as it relates to going through your solenoid or your pulse width sprayer. What you'll find is the minimum speed is your 25% duty cycle. While it is possible to get down there, it isn't recommended. So that's just kind of a bench line to have the minimum speed. And then the maximum speed is the amount of spray that you can get out and how fast to keep your rate on. So in this case, at 40 psi, we'll see we can go upwards of 15.3 miles per hour. So the troublesome part is you probably saw pretty quick there's a lot of red here. So what that signifies is that the speed is restricted. So given we wanted to apply at 15 miles per hour at 35 psi, the nozzle will be restricting the flow. So where you see this duty cycle in the next column here is over 100%, which isn't really possible. So we'd struggle to get our rate out. In this case, we might have to slow down if this is the nozzle that we're going to be using. But more often than not, we'd actually be selecting a nozzle that's larger. So before we've gotten into anything else as far as the columns go, we'll discount this MR104. The only time we might consider it again is that since the spray quality and such is garnered at a higher pressure, the higher pressure allows a little bit more room for the duty cycle and speed range. This might be a good nozzle if we do have alternate applications that need, a 5-gallon rate as well. So this MR104 size might be a fairly solid 5 to 7.5 gallon nozzle, but not much more than that, because you'll see a flow capacity issue in the faster speeds or the higher rates. So with that in mind, we will go to the next size up, which would be the SR105. The SR105 is the next size, but also a series finer than that MR. So we'll click into that, and then what we'll find is that, first of all, the red is nominally there. You'll see it at 25 psi. It isn't so much concerning because at that low of a pressure, we're not typically going to be going or spraying that low very often. So in this case, at 25 psi, we're maxed out on our duty cycle. But the troublesome part is that most of the time, we don't want to be spraying at 25 psi for spray quality reasons. So we aren't going to be hindered so much because of that 25 psi. We'll take with a grain of salt as far as being a reasonable nozzle choice still. So for this example, at 40 psi, our duty cycle and speed range is sufficient. As far as duty cycle side of things, you'd want to try keep it between that 60 and 80% duty cycle. Again, just so that you have enough flexibility on the speed range, both up and down. But more importantly, if you do have a turn compensation mechanism built into your pulse width sprayer, so again, reminding you that if your center rack is going 15 mile an hour, as soon as you deviate from straight, the outside section that's swinging hard is going a lot faster. So with turn compensation, what it does is uses that extra capacity. So in this case, we'd have 80% of our spray in the center section, meaning there's 20% more or extra capacity on that outside section that's swinging hard. So turn compensation is able to take advantage of that extra capacity, open those solenoids out for longer of that duty cycle, and put more chemical out such that you'd have a more accurate rate going down in those corners. So 80%, great, no issues there. 60 to 80% is a good bench line. Not much penalty for going up or a little bit lower than that. But where you want to have, be free of is the trouble zones. So the trouble zones being at the low end of the duty cycle. So usually between 40 and 50% is not really a good place to be. Anything below 40%, and you definitely don't want to be there. What ends up happening is that, for an example, or more of an extreme example, if we're applying at 40 psi at 4.7 mile an hour, which I mentioned before is our 25% duty cycle, the nozzles themselves and the solenoids are working in pairs, so spraying in each other's off time. So if you're only spraying 25% of the time out of the nozzle, pairing that with the one beside it, overall your sprayer is only spraying half the time. So what you can end up doing is get yourself in the realm of having checkerboard. Again, you pick your nozzle right, you're not going to be getting that kind of grief, but it is something to be aware of just because it does have a pretty big impact on the nozzles you choose. So in this case though, reminding you, 80%, we're good. Now we've qualified this nozzle to be sufficient on flow and speed, so we can carry on. So the classification column, that's that ASV classification that I mentioned before. So in this case, it's a coarse spray quality. So even though the nozzle, the chemical label might be recommending kind of medium droplet size, what ends up happening is that being between that medium and coarse, we've kind of hit a sweet spot, and I'll show you as we kind of carry on. But the next column here is a VMD, so that droplet size I was mentioning before. So it'll highlight green based on the closest droplet size to what we searched. So at 40 psi, our droplet size, again, roughly around that 330 microns. So again, the filter has been met. The next two columns is where it gets a little bit more interesting. So the first column here, the percent less than 141 microns, that's the driftable fines. So again, that's in ideal conditions how much spray is likely to drift. Again, drift being qualified as not only off-target spray that blows, whether it be 5 feet, 50 feet, or 500 feet, but also the amount of evaporation as well before plant contact, which isn't ideal. So with this percent less than 141 microns, that's going to be the driftable fines. So with that, 10% is pretty well in ideal conditions going to be drifting. Again, when conditions are not ideal, again, ideal being one of those situations where we do not often get ideal spray quality, keep in mind that that will differ with spur speed and wind speed. So if you're considering, a wind speed of 12 mile an hour, you can pretty well consider that 10% to be doubled. So roughly 20% of your spray would be less, small enough that it could be drifting. So on the flip side, because often what ends up happening is that operators will be looking at that driftable fines and trying to minimize it, keeping it as low as you can. But to balance it out, you got to remember there's a coverage factor to keep in mind as well. So in this side of things, on the next column, you'll see the percent less than 600 microns. So that's a percent of small droplets. So how much of your spray is made up of nice and small droplets that are useful for coverage? Anything bigger than 600 microns, effectively it's getting to the point where it's going to hit a leaf and roll off. So drip isn't going to be giving you much coverage, but also too, it chews up the water volume that you're applying as well, so making it less effective. So we want to try to keep this number as high as we can while keeping our drift as low as we can. With drift itself, there's not really a good way to minimize it to zero. Even the coarsest nozzles in the world, that would be, for the most restricted herbicides, they're still going to be in the realm of that 1%, 1.5%. Drift does happen. So it's just a matter of relating a relative driftable fines that's acceptable for your conditions and the chemical you're applying and making it work. So for something like Liberty, which is a contact herbicide, you might be trying to keep within 15%. So 15%, so 15% of your spray might be driftable, and that might be okay. Again, you never want to be at the top end of it, but it's more of a situation that to have that bench line is useful in making spraying calls. So in the situation that it is getting a little bit windier, that might be a situation where you might consider doubling that driftable fines number, which if we double that 7%, we're at 15 or 14%. So we might be just below that 15%. So that's kind of the calls that might be made during the day in real life conditions to try cater your spray quality a little bit better to your conditions. On the flip side, for the coverage side of things, if we're trying to keep our driftable fines within 15%, we're demanding a high level of coverage. Because of the mode of action and the chemical we're applying, we demand a higher level of coverage such that it can do its work. So what that higher level of coverage might look like for that bench line might be around at 90% or greater. In this example, we're over 90%, so 93% of our spray is nice and fine, while 10% of that is drifty at the very least. So that's a pretty good place to be as far as that bench line. We do have that means to drop our pressure on the go with our Pulse Width sprayer, such that at 30 psi, we can drop our drift down by almost a third, while still maintaining a high level of coverage. So this might be a good nozzle for that situation that a farmer does not have the worst conditions to apply in. You're not dealing with high winds all the time, or a smaller farmer that might be able to be a little bit more choosy on the spray days and such. So, but all in all, our rules of thumb are satisfied, being under 15% drift and over 90% coverage. So this might be good nozzles. If you do have situations where you're applying a lot more volume with a nozzle, so if you had a 7.5 gallon rate for Liberty, but also a 10 gallon rate as well, that might be a consideration for the next size. So this SR Untitled 5, as you noticed, there's some red, meaning that the flow capacity is almost being met. That might be enough signal that we say, hey, this 05 might work for me exactly at 7.5 gallons, but anything much more than that, and we might be restricted. So with that, we'll go to the next size, which is the SR 11006, so the 06 being the next size up. What we'll find, again, the duty cycle and everything else will change. It'll go down because it's a larger nozzle. So at 60 psi, that's where our droplet size is closest to 330 microns. We're in the realm of 55% duty cycle. So while I mentioned the ideal being around that 60 to 80%, that isn't necessarily the trouble zone yet. We're not getting ourselves into trouble at 55% duty cycle. While it might not be ideal, you think of it this way, that the plumbing itself is just a matter of efficiency. Are you able to get it all? At 55% duty cycle, we are. If that makes sense. The troublesome part, and where operators might get themselves into a little grief is that if that 15 miles per hour is your maximum speed, but you're typically applying at 12 to 13 mile an hour, that duty cycle will be lower. So to calculate your duty cycle at any given speed, you divide your travel speed, so let's say 13.5 mile an hour, divided the max speed at that pressure. So in our case, 27 mile an hour. For the speed 13.5 into 27, we're exactly at a 50% duty cycle. So you can do that at any speed. That's nice to use when you're doing actual charts, printed charts, not interactive charts like this. And it is worthwhile knowing just where your minimum duty cycles might be. So this might be an application where in ideal conditions where you can maintain a higher level of speed, you might be spraying at 60 psi. At 60 psi, you'd be at roughly 11% drift, which is still within our benchmark of 15%. And our coverage factor is above 90%, which is good. So we're not going to be short of coverage. What this nozzle will do that the SR105 cannot do is that it'll be able to put out more flow. So this might be a nozzle that's 7.5 to 10 gallon range or so. But also too is that you have a lot larger means to drop your pressure on the go. So from anywhere from 30 to 60 psi, that's your pressure swing. And what you can do with that is that in those conditions that are less than ideal, you're not at all restricted in the speed and pressure, because if you drop it, it goes up, but not near, not near 100% duty cycle. So 35 psi for an example, or 72% duty cycle, good. Our spray quality got considerably coarser, which makes sense. Lower pressure, larger droplets. Drift or driftable fines went down almost by half at the cost of roughly 8% of your spray and coverage. Again, big droplets can still give coverage and such like that, but when we're talking making the decision before we're getting into the field at all, we want to try to keep it above 90%. But keeping in mind that this is not our typical spray application coverage, this is when the drift sensitivity trumps coverage, if that makes sense. So 84%, we're a little shy of where we wanted to have 90%, but that's a pretty good trade-off for when we need it. For whatever nozzle you do choose down the road, there is the print icon. The print icon can be clicked on any result nozzle, and it'll generate a spray tip chart for your specific application, for your specific spray conditions. So again, the Pulse Width sprayer you're using, nozzle spacing, everything else. Very good and very handy to have in the cab. So literally just having it, even double-sided with another nozzle sheet, so you know exactly what your capability is with that nozzle, spray quality, driftable fines, and that kind of stuff. So you can make the decision while you're in the cab there just by clicking a button. So that's available. Also, there's the star for favoriting the nozzles. So earlier we mentioned there's that option to search favorited nozzles previously. That's how you do it. But simply enough, between these two nozzles, or I guess three nozzles, the MR104 might be used more if you're applying lower rate volume that is similar. It gives a fair bit of driftable fines reduction just by changing pressure and still a high level of coverage. The SR105 at a kind of normal 40 psi gives a high level of coverage with, again, relatively okay driftable fines. Does not give the most room to drop your pressure, reduce drift, but for some people that need exactly that 7.5 gallon nozzle, it would definitely suit. The SR106 operates similarly, being a little bit larger of a nozzle. It does have a lot more capacity to go down in pressure to reduce drift, and also a much greater capacity to do more volume out of that same nozzle if the situation had called for it. So, all right. If you do have any questions, again, by all means, give a shout by either even on the website. You can send a message there, which gets straight to us, by Twitter or a number of the forums or farm forums we're involved in as well. So definitely give a call in if you have any questions, just to give you a hand. We're always there for you. Okay, take care.